All right. Okay, and yeah, maybe you're a little rusty with it. So we want to, again, when it says rationalize the following fractions, we don't want a radical in the denominator. That's considered not simplified. So, any thoughts? I thought I heard it over here. Yeah.
Multiply by the square root of 5.
Yeah, if we multiply by the square root of 5.
Over 2, I should have done
Now, square root of 5 over what?
the square root of 5 like so 1.
Yeah, so we can multiply the top and bottom by the same thing because square root of 5 over square root of 5 is the same thing as multiplying by 1. So the reason she chose square root of 5 is because square root of 5 times square root of 5 is 5 because it's square root of 25, which is just 5. So we want to get that radical out of the denominator. Now I'm going to go like probably slower in steps than some of you guys want, but again, kind of trying to slow down. For some of you that maybe this isn't coming as easily or you don't remember this as much, it's okay. So I multiplied those together, and square root of 25 I know is 5. But this one can still be simplified. What can we do with that? Divide. You were giving me the answer, yeah. Divide by 5, it's going to be 2 over 1 or just 2 square roots of 5. Now again, some of your calculators will do this simplifying for you, and that's okay. It's just
We should say, oh no.
We won! Did you shut his door?
No, I should. Yeah, because you should.
Yeah.
Next time he does it. Okay.
Good job, team.
All right. Why don't you guys look at letter B and determine what you guys think we should do there. I'll give you guys a little bit of time to think about it and see. That one's a little bit trickier, but at the same time it's a similar idea.
Oh no. Oh no.
What?
Danger.
Oh my god!
Oh, now I forgot I have trig breaks.
Go slam his door. That was so bad. She just like peered around the corner. She's like, look at what Mr. Hatfield started. Now he's gonna regret it.
We have the whole school there. I wonder if he can hear that. And it's filming right now. I'm sorry.
Awesome.
No one's not here though. Everyone's here though. Okay.
I'm watching it. I'm going back to this. We got him. We got him. Hold on. Should we go to his room and yell? Should we go in front of his and yell? So I was not That's what I'm going to be like. We're actually doing it on purpose. Oh, jeez. Come on.
We know why now.
Oh, my cheeks
He
hurt.
he walked up and closed it.
Oh my goodness. Okay. I feel like I can't even start talking because I'm afraid someone's gonna yell at me. If I can start talking. All right. Can we make a truce?
I think we need a one more yay. Please, Mr. Hatfield, is you okay with it, man?
He's helping.
3, 1, 2, 3.
1.
Good job, thank you very much.
Stress release. And we go.
Yeah.
Yes, sir. Yes, sir.
We take dubs.
Yes, sir.
Big dubs.
Big dubs. Fat dubs. Big dubs.
I don't think they can repeat. Come back. It was. Where does it come out right? Too big of a burn.
Alright. Jones.
Let's go! I got it by myself, Let's go!
I wonder at what point it stopped. Okay. Okay. So anyhow, we haven't gotten through the warm up yet. All right.
I got distracted.
You got distracted. Okay. So yeah, break. Okay. So.
Hey, we just won that.
All right. So brain break. I think that might have been it. But okay. So.
Super my fault.
I'm like
You
literally.
gotta stop now, though.
Yeah.
I really am gonna have like PTSD. I'm afraid to start writing because someone's gonna yell. Like.
I'm rolling. It's all my fault.
Take it away, take it away. Ready? No! Sorry, I don't like to lose. Can't lose. He's like apologizing for that.
The whole class walks out of the office.
I'm sorry.
No, do not.
No, Joe, get out! Out!
Okay, yay from this time. 1, 2, 3.
I would lock your doors.
Oh, you better stop the video when you start it.
Yeah.
You better upload it.
Nobody enters, nobody leaves.
Okay. So, letter B. So Erica told us in this one we wanted to multiply by the square root of 5. What do we want to do in this one? What do you think?
Find a common.
Multiply that square root of 7.
I lost my train of thought.
So the question is, do we want to do 7 root 2?
Yes.
Do we really? Did you say 3? Does the 7 really? Do we have an issue with the 7?
I do.
No. So let's kind of ignore the 7. What can we do to get rid of the square root of 2? Multiply the square root of 2. Now you could multiply by 7 square roots of 2. However, just kind of like when you're finding a common denominator, the smaller numbers are a little bit better. So if we can kind of keep this to a minimum of whatever we're doing, we can multiply by the square root of 2 because that will allow us to cancel the part that we don't like. We don't care that there's a 7 there. And some of you guys who are doing some of the ones with the eyes with in pre-calc, it's kind of the same idea. You don't have to multiply by, like 7i or whatever it happens to be. So this becomes 5 square root of 2 on the top. On the bottom, it's 7 times the square root of 2 times the square root of 2, which is the square root of 4, which is just going to be 2. And then 7 times 2 is 14. Now, it is important to point out you cannot cancel those 2's. One's underneath the square root and the other one's not. So you can't just cancel them because you see both the 2's. Okay. If you guys are thinking about being sleepy after lunch, like that is no longer.
Yeah.
It's so much you should wake up like your siblings in the morning. Just walking up. So,
It is snowing out on my road right now.
I saw flurries this morning in my drive-in.
I wish it like actually snowed.
I think we might get an inch. They're saying maybe an inch, but yeah.
It's our chance.
All right. Okay, guys. So probably half of our notes today. Probably half of our notes today look really super familiar. The other half probably looks like we're learning a new language. And I mean by half is if you look at the left column on most of these, sine, cosine, tangent, you guys have seen that before. The other half you might not have seen before depending on your background with what you guys got covered in different classes. So our normal trig functions are sine, cosine, and tangent. However, we've been leaving something out. There's like the stepsisters and of these trig functions is so cosecant, secant, and cotangent are the other trig functions that we haven't been mentioning.
Do you have those buttons on my calculator?
Good question. You actually don't have those buttons in your calculator. Actually, your graphing calculator might, because we might need to do that for like if you're actually graphing it.
Nope.
All right. So, where these other trig functions show up is they're actually just reciprocals of sine, cosine, and tangent. So remember, this is SOHCAHTOA. Cosecant, secant, and cotangent are just the reciprocals of that. What's the reciprocal?
Backwards.
Reciprocal. You guys should know what the word reciprocal is.
Opposite.
Flip, thank you. It's close together.
Let's go. Good job, Owen. Good job.
We were just doing reciprocals the other day.
You're welcome.
All business, all business.
Oh, don't forget. I will break your pencil now.
Is it?
Okay, so guys, so it's a little bit tougher to like just say it's just like flipped over exactly because we're gonna call this sorry, the abbreviation for this one is CSC for cosecant. Cosecant, rather than being like sine, cos, tan, they do CSC for cosecant. And what this is, it's going to be 1 over the sine. If you want to do an angle, it doesn't really matter. No.
We're gonna get a cheat sheet on this test, right?
Yeah.
We get cheat sheet,
Well, there's parts of this test that you don't get one, but we'll talk about that later. You'll be.
You lied.
I'm scared.
Don't get what?
Come on, wait, we don't get a calculator?
What? No, parts of this test you can't use a cheat sheet on. This next one.
But I can't do math.
So all of these are just reciprocals of the original function, and so when you actually want to use them in your calculator, you actually use the inverse sine, cosine, and tangent. So if you want to use the button, it's right above. It's the same one you used to use for the for the angle.
So all these times that you say are the inverse sine, it's really just doing that?
Yeah, I mean it makes more sense to call it inverse sine when you guys are doing that because you're finding the angle. Yep.
So we're not, yeah.
I agree.
So instead of doing the 1 over sine of the angle, we're just doing the sine and then the angle.
Yeah, you would. Yeah. Well, like if you were trying to do the secant of an angle, you would do the inverse cosine. All right. I'll be honest, you guys. You're not really going to do a ton of calculating. I mean, I wouldn't choose to use cosecant very often. They do want you to understand what the ratios are set up as, and sometimes we will graph these and work with them that way. But for the most part, cosecant, secant, and cotangent, I don't use those very often to solve triangles. Like tonight's homework, you probably won't use them other than setting up some ratios. And I'll show you guys what that looks like here in a second. So if this is our angle theta, we have our opposite over our hypotenuse, and then our adjacent. So sine is over h. So what would that mean for cosecant? Yeah, you just flip it.
So how do you?
So I would not suggest I wouldn't probably suggest trying to learn an acronym for that one, so I wouldn't call it CHO. I would just remember that sine and cosecant go together, and you're typically going to write them both at the same time. So you're just going to flip it each time. So I would not probably learn a new acronym. I would probably stick with this one, and then just know that cosine and secant go together. So like kind of try to remember the one it goes with. The way I remember it, obviously tangent and cotangent sound alike, so those two go together. These ones, I always think about it flipping, so the front letters flip. That's kind of my way to remember the difference. So this one's adjacent over hypotenuse. So then this one would be hypotenuse over adjacent. So, if you guys could take a minute in example 1 to actually set up the fractions. So see if you guys, so we have our angle theta, so just setting up those fractions and those ratios that go with that. I'm going to pause my video because